Okay, so thanks for attending, guys. Today we will be continuing with the topic that we have discussed yesterday. The topic that we have discussed was Move It. Move It was um, s- meta package or like a ROS stack, I will say, for creating manipulation application like pick and place, then yeah, so these kind of application we can implement using MoveIt. So mainly MoveIt is applicable for robotic arms. Okay, so we have seen an introduction to ROS MoveIt yesterday, and we have configured a MoveIt package for a robot. Today also, like, we will see like the step-by-step instruction to create the MoveIt configuration package for your robot, and also we will see how to program the robotic arm specifically using MoveIt. Okay, we can also see some pick and place examples from the tutorial. So basically, I have mentioned, right, this is the official MoveIt tutorial um, website. Maybe I can share the link. I think I have already shared yesterday. So we will be just going through this tutorial and then work out some examples. So this is what we are going to do. Okay, so I mentioned that we can start from the configuration package. Like if you have a robotic arm, and if you have the robotic arm model in the form of URDF, okay, then you can create the MoveIt configuration package for that model. Okay, so if you have the MoveIt configuration package, then you can do the path planning and all, like moving the robotic arm from A to B. So the main requirement is the robotic arm description package. Description package means the package which is having the URDF model. Okay, so maybe we can start from that. So guys, like just have a look onto this example. Make sure the version of the ROS that we are using is MoveIt 1 Noitic, and then just start with the getting started. And in that you can see the instruction. First, the instructions are for installing ROS and some tools. Okay, and next is the instructions to set up the MoveIt packages from the source code. Okay, so while working with ROS, you can install a package or you can build a package from the source code, or you can install it from the binary. Okay, binary means you can use the command sudo apt install for installing the ROS packages. For example, for Noitic, just use ROS Noitic and MoveIt. Okay, so you can see a list of packages starting with ROS Noitic, MoveIt. So these packages, no, these packages are actually the binary packages of MoveIt. So if you want to get the latest version or some specific version of MoveIt, what you have to do is you can just follow this instruction. So basically uh, we have to create a repository, and there is a software tool called WS tool, which is mainly for downloading the dependency of MoveIt. So this is the instruction. If you just search for WS tool, you will get the um, description. So it is for like fetching libraries which can be used for building a repository. So this is the instruction to build the MoveIt packages from source, but we are not using it. The next thing is what we are using, which is downloading some example code. Okay, so we are actually starting from here. So we have a package called MoveIt tutorials, and we have a package called panda MoveIt config. Okay, so this is the two packages that we are going to use. Okay, and so let's start. Okay, so in order to download this tutorial, just create, I mean, you can simply create a workspace called WS MoveIt or something. I mean, you can give the name and just clone this repository called MoveIt tutorial. I think I have already cloned the repository in the workspace. Yeah, so MoveIt tutorials is already here, and I also want to clone the Panda MoveIt config. I will explain the package in detail later. So these are the two packages, example packages that we are using for this session. Okay, and in order to build the packages or build this workspace, just use this command. It's basically like switching into the workspace, and then before building the workspace using catkin make, you can install some dependencies using ROS dep, okay, which is a command that is available in ROS. So this will be like installing the necessary dependencies. Yes. Okay. Yeah, so after setting this package, we can start with the tutorial. Okay. Um, Before that, let me just check for a package. So we are actually setting up this workspace, which is having the movie tutorials, and yeah, and we have the Panda MoveIt config. Let me see. Okay, it is okay, and let me check. Yeah, we have to wait for that, and after that we will start with the MoveIt setup assistant in a new robot. Okay, so this is the instruction that we are going to follow. Yesterday I have shown you some step, but today we will be seeing it in detail. Yeah, and also the instructions are mentioned step by step, so you can check that. Yes, let me see. Okay, MoveIt config. Okay, let me check the status. Okay, so all these things are installed. Now you can use the catkin make in order to build the example packages. Let me see whether that is taking time or not. Okay, I think there are some dependency that we require. Okay, let me check. Okay. Okay, so not available. Yeah, maybe we can set that later. Maybe as of now, we can start with the Panda MoveIt config. Let me just move this package to downloads. Okay, so we only have the Panda MoveIt config, guys, and just building the repository, I mean workspace. Okay, so we have the package called Panda MoveIt config. Okay, just a second. We have to source the workspace. So this is a new workspace, right? So in order to access the packages inside this workspace, we have to source it. Okay, so one of the easier way to source a ROS workspace is just open bashrc in the home folder. Okay, and just go down and then add this line. okay, which is sourcing the devel, the script inside the devel folder called setup.bash, and then you can try the ROS CD. ROS CD. Yeah, so you can see the ROS CD is working and it is pointing to the MoveIt config. Okay, yes, so that is one thing. So using this config package, we can start with the setup assistant. Okay, so that is first I would like to show you. Okay, so what is this package? This MoveIt config package. So this is how a MoveIt configuration package for a robotic arm looks like. So if you are working with UR5 or Kinova, Jacko, the MoveIt config package will be like the name of the robot underscore MoveIt underscore config. And what is this package contain? The package is having some configuration which is storing during the wizard, during the setup assistant wizard, and also it is having some launch file. So these things are automatically creating, and basically the MoveIt config package is a ROS package, okay, which is having package.xml and CMake list. So what we are going to do now is we are opening the setup assistant. I think you may be remembering that command, right? You can open MoveIt setup assistant package. In that you can start the setup assistant.launch, and oh, just a second. Maybe I need to reinstall. Just a sec. Let me check the command is correct or not. I think the command is correct, but yeah, let me just reinstall this package. MoveIt setup assistant. I can use the Synaptic package manager, which is a GUI of the apt-get. Okay, so what I'm doing is just searching for the MoveIt setup assistant. You have to replace the underscore with hyphen, and then you will find the setup assistant. Okay, so just upgrading it and see whether the launch file will work or not, because before this I have built the source code of MoveIt, so I'm not sure that actually made some issues with the existing binaries. So just wait for some time and let's see the launch file will work or not. So what we are trying to do is we are trying to follow this tutorial. So in this tutorial they actually first show you how to edit an existing MoveIt config. Okay, so by editing an existing MoveIt config package, you will understand different configuration that we have to set inside the package, and then we will generate a new package. Okay, new package. Okay, so that is what I'm trying to show you. So this is complete, and let me try again. Okay, seems like there is some problem. Let me try just okay. ROS launch, MoveIt setup assistant, then setup assistant.launch. So it seems like it is popping up with an error. Yesterday I think this error was not there, so we can check. The error is cannot locate node MoveIt setup assistant in package. So they are also saying a solution. We can use a chmod to fix it. So I will first try with the chmod. Let's see. let me check. Okay, Tejas is having suggestion. Move it setup is present in the in the second workspace and both are source. Maybe that may be the conflict. Maybe because I have set up the move it config. I mean the same package in another workspace. So maybe using the ROS CD we can find. So currently I think it is taking this binary package, but let me see if any other package is making the issue. Let me search first. Move it setup. Yeah, so seems like uh, this yeah, on the devel folder. Okay, so maybe what we can do is we can simply delete the build and devel from the move it workspace, and then let me check. So the thing is that in the bash RC, we are actually sourcing only the move it workspace, so only that, and there is nothing in other workspaces. So what I did now was I just deleted devel folder and build folder from this existing workspace, and then I'm just building again using catkin make. Okay, okay, so that is done, and then I'm trying again. Setup assistant is there. If I'm starting the launch file, it's actually throwing some error, so it might be the problem with the workspace, it seems, because when I change that, it is coming up with a different error. Maybe I can reinstall the package and let's see if there is any changes. So Tejas is having a suggestion: if you remove WS move it from bashed and source it. Yeah, so that is not actually I mean it's already having the sourcing inside the bash RC, but now we don't have the devel, I mean the previous build and devel. So I think that may be the solution. So let me reinstall the MoveIt setup assistant and let's see if that solve the issue, because currently we don't have the source code in any workspace, it seems. Okay, so let's see whether that works or not. Yeah, we have reinstalled it, and let's start the setup assistant again. Oh, okay, so this can be because of the yeah, I got an idea. So we if we are upgrading any packages of MoveIt, we have to upgrade all the packages. So I'm just clicking it each packages using Synaptic. So simply clicking it will be updating the repository, updating the packages mainly. So let me just update. Otherwise there will be clashes based on the versions. So here I'm trying to trying to update all the packages which is having MoveIt, I mean which is already installed. Okay, so basically I'm updating and just wait for some time. It is downloading, and yeah, it will take some time to unpack. Yes, so this is what happened if you build the MoveIt from the source code and install MoveIt from the binaries. So just before the session I was trying to like build the source code, so I think that's how it is happened. So let's see, let's wait for installing the binaries. And now we can run this command again. Yeah, now it's worked. Okay, so it's worked. So yeah, I have updated all the MoveIt packages. So here you go. And what we are doing is we are going to edit an existing MoveIt configuration package. So just click this and then just browse the package that in the WS workspace, WS MoveIt workspace. This is the package, and just take this MoveIt config package and just press open and then press the load files. So it seems like it is complaining about the sacro. So this was the same issue that we had it before. Let me check what is happening. Okay, yeah. So the problem is we need so what is the error? Yeah, Franga description robot. Got it. Okay, so it is complaining that the MoveIt package that we are editing, it actually require the URDF file from a package called Franga description. So the robot that we are working, that we are going to work is called Franga robot or Panda robot. Okay, I think, yeah. So this is a robot. So for the MoveIt config now, the MoveIt config package actually dependent on the Franga description. Okay, but when the setup assistant check for Panda URDF, it is not available. Okay, so that is the current error that we are getting. So maybe what I can do is I can simply search for Franga description and we can check where is this description package. So this is the description, I mean this is a repository of Franga robotic arm, and what we can do is we can simply download it and then we can take the description package from here. I understand that you may have some confusion, but let's see, after this we can discuss in detail. So we have the Franga description here, and what I'm doing is I'm just copy paste this package in the MoveIt workspace, and what I'm doing is I'm doing a catkin make in order to build the workspace, and I'm also checking whether the Panda description package robots is having the robot the sacro inside it. So I think the problem is that inside the robots there is a Panda folder. Inside the Panda folder there is a sacro file. Okay, so let's see. Let's open the setup assistant again and go to the edit mode, and then open the Panda MoveIt config, then load file. So it seems like there is a problem in the path. Okay, so for the Franga robot now, for the Franga description, it's actually inside the Panda folder, like Franga description / robot / Panda folder. Okay, so maybe what we can do is we can simply modify the MoveIt config. Just go to the am.sacro, I think. Let me see. Don't worry about this line, I will explain it later. Okay, pandas RDF sacro, yeah, MoveIt config. Okay, not here. Let me search in the Sacro. Okay, Franca. Not here. These all are the launch file. Yeah, it may not be here. So mostly, I think, let me open it. So setup assistant. Going to the edit mode and opening the Panda MoveIt config. Yeah. Okay. So we can do two fixes. Just a second. First, let me see where is the Franga description. Okay. So it's in the MoveIt workspace. So either for a quick fix, we can just copy paste this into here, and then we can start the setup assistant and load the config. Okay, so it is still complaining that panda arm.urdf is not available. Just a second, let me rename this file. The name of the file is actually different, so let me load it again. Okay, so it actually solved that issue, but there are some more issues existing. So what I can do is, I think there is a problem. So what I can do is, I can start with the new one. Let me try to solve this because there are some path issues in the existing MoveIt config. So that need to be solved, because for the description package, the path is new, but for the MoveIt config, it is actually different. So maybe what we can try is, we can try to create a new config package from the Franga description package. Franga description package is having the robot model. So just opening the Franga description. Just a second. Let me see. Oh, it's in the robot. Let me see. Okay. So it seems like Sacro is not defined. There are some errors, it seems. Okay. Let me check. Robots panda join limits. Okay. So this is the file, and this is the Sacro file. So seems like there is nothing. Yeah, there is no problem with the Sacro file, it seems, but it is not working. But let me try to visualize the same. Or maybe I can try with this. Just a second. Create new package, and workspace MoveIt. Sacro, load files. Yeah, it seems like there is an error. I need to check that. So name Sacro is not defined. So let me just search what is the cause of it. um, yeah, it seems like a non-issue. Yeah, it seems like we need to change something in the, so it seems like a non-issue in the Franga ROS package. Okay, so this is the, I think this kind of issues that we are getting. Okay, so I think in order to not waste our time, maybe we can switch to another robot, that is the Kinova. So that is the best way, I think, because I'm seeing some differences between the Frangar description and MoveIt config. So in order to save our time, just let this package be here, and we can just continue with our own packages, that is the Kinova robotic arm package that we have tried yesterday. So I can use the setup assistant for that. So yesterday we have seen, right, we have uh, seen how to create the new MoveIt config package. So let me try to take the Kinova robotic arm from the workspace. So this is the description package, and I am just pointing to some sacro file, maybe, yeah, so this one, and I am loading it. So this sacro is loading perfectly without any issue, and then we can follow the instruction which is mentioned in the tutorial. Okay, so I think we can do like that. So first, if you have a robot model, you can press the create new MoveIt configuration package, and you can see the robot on the right side if everything is successful. And the next thing is the self collision. So if you want to generate a collision matrix, that will be helpful to do the motion planning effectively. So we can see which all are the joints are enabled and which all are the joints are not enabled. Okay, and I mentioned that the virtual joints from the tutorial, you can see it is actually for I mean, if you are working with a mobile robot, then this virtual joint may be useful to connect with the mobile robot. Otherwise, you can just make like this. I mean, you can just add virtual joint and give the name virtual joint. Maybe I can just move this tutorial to right, yeah, here. And then what was the childing? So childing should be the base link. Okay, base link of the robotic arm. And then the parent frame, you can name it as world or something, and it's a fixed joint. So this is actually a virtual joint, meaning there is no actual joint like this, but we are creating a virtual joint in order to connect into the world. Okay, especially if there is a mobile robot that is mounted, I mean, if a robotic arm is mounted on the mobile robot, we can use a virtual joint. Okay, so just saving it, and then in the planning group, I think you remember, right? We have to define two planning group. One is for the robotic arm and one is for the gripper. Okay, so for the robotic arm, you can give the name of the group, then select the kinematic solver, and also you can add the joints. Okay, joints, yeah, that will be fine. And for the gripper, we have to do the same. Either you can add the links or you can add joints and links, no problem. So what I'm doing is I'm creating a group called arm, And for the arm, I am just assigning the kinematic solver as KDL kinematics, and I am adding the kinematic chain. Okay, so the base link will be this. Okay, and you can add the tip of the or I will say the wrist of the robotic arm, which is the bracelet link. Okay, after that there is an end effector link. So let me see which is the which is the joint that we can make it as end effector. It seems like, yeah, it seems like the end effector link we can use. Okay, bracelet link will also work. Bracelet link is here. Okay, and the end effector link is here. Maybe I can choose the end effector link as a tip. Okay, then saving it, and I can also add a group for the gripper, and we don't need any kinematic solver for the gripper, but we can simply add the links and joints. So these are the links of the gripper. Okay, yeah, I think that is enough. We can save it, and we can also mention the joints. Let me select the joints. Yeah, from the gripper joint we can add all other joints to it, and saving it. Okay, so we have added two planning groups, arm and gripper. I think that is enough. Arm and gripper. Okay, and after that we can define set of poses. Okay, like home pose or something. So just put home, and then you can set some poses like this. Okay, just say this is the home pose. Here you have the control over the joints. Okay, so save it. So this is not very important, but you can do it. Okay, it's an optional setup. And in the end effector, so let's see the end effector. So here you have to name the end effector, and then you have to assign the parent link of the end effector. So what I'm doing is I'm adding the end effector. I'm just giving the end effector name as gripper again, and the end effector group is gripper. Okay, because this is the group that is yeah, that is actually having the end effector, right? And then the parent link of the gripper, so it will be the robotic Q base link, it seems. We can put it as end effector link. So that was the tip link that we have given. Okay, so we have given that and saving it. And then passive joint, if there is any joints that is not participating in the motion, or like the joint doesn't have any actuators, you can mark that. Currently we don't have any. And now we have the controllers. So these are the controllers that we need to assign in order to interact with the external robot. It can be simulation, or it can be the actual robot. Okay, so if you press the auto add follow joint trajectory, so this will create a configuration file for the controllers. Okay, So this controller is actually sending the trajectory from MoveIt group, I mean the move group, that is the node, right? So when you press the execute button, this trajectory, the trajectory actually created by MoveIt is sending to the controller. Yesterday we have discussed the controllers inside the MoveIt, right? So basically, when you press the execute button, this controller configuration, or this controller, the MoveIt is a controller client, and the gazebo or the real robot is acting as a controller server. So this MoveIt client is sending a trajectory to the server. It can be gazebo or it can be real robot. So this trajectory is going to send. Okay, so we have to keep a configuration in the MoveIt side to send the trajectory to the gazebo or to the real robot. Okay, and if you are working on the simulation, you have to copy these things, like you can see in green color, right? You have to copy this setup into your URDF file. Okay, so that is important. And also you, just copy the things in the URD file. Like you can see the transmission tags, which is actually it's called a hardware interface, or like these tags are important in order to assign controllers for your robot. Okay, like the transmission tag is having descriptions of each joint, whether it is having gears, or which kind of controllers are we using, mechanical reduction, all the things are mentioned in the transmission. So basically, in the robot model, there is links and joints, right? So each joints are connected to a motor. Okay, so and each motors are connected to a controller. Okay, so we have the controllers, and controllers will control each motors, and these transmission is like the configuration of that motor. Okay, or the joints, like the gear ratio, or like what kind of control that we are using, whether we are using effort, torque based control, or something like that. So actually the wizard will be automatically creating this configuration. So just copy paste into the URDF file if you have. Then in case of the 3D perception, if you want the 3D perception, just map the, just give the topic name of your depth camera, and also I think you have to mention the frame. I think that is not mentioned here, but I think we have to mention the frame as well. Okay, anyway, yeah, so the point cloud, but we are not using it for now. We can put it none. And then the other information, like I can give my name and the mail ID. Okay, and the configuration files. Okay, so this is the last step, that is the generation of the MoveIt config. So here you can browse the path first, and just create a new folder called Cortex MoveIt. Okay, create it, and then so these configuration, these entire configuration will be writing to this package. Okay, this package. So just press the generate button, and the generation is completed, and then you can exit it. So if you go to WS MoveIt, you can able to see the Cortex MoveIt, which is having the config file that we have generated, and also the launch file. Okay, so this is how we can create the configuration. Okay, and After this, what you can do is you can build it. You can build the workspace, and yeah, so it is actually detected as a package, but the package name, if you just go to the Cortex MoveIt and if you check the package.xml, the package name is also Cortex MoveIt. Okay, so now just play with some auto-generated launch file inside the configuration, Cortex MoveIt and demo. There is a launch file called demo.launch, so which is actually showing the robot with the planning, but it is actually going to execute the trajectory in a fake controllers. I think yesterday we have seen that. So now you can interact with the robot. Just set the goal position, plan it, and execute. Okay, and yeah, for the gripper, you can try to select a random position. Let's see that is working or not. Yeah, currently the gripper is open and we are commanding to go to, I mean, closed position. So we can see, yeah, see the gripper is actually closing, and if you execute, you can see the fake execution is happening. Okay, so this package, the MoveIt package that we have generated, can able to do the motion planning, and it can able to send the trajectory to a gazebo simulator or a real robot or to a fake controllers. Okay, if you only want to interact with the robotic arm in RVs, you can use the fake controllers, but if you have the gazebo, then you can use I mean, you can configure the controllers in order to send to the gazebo. I will show you that next. Okay, so this is the basic steps in order to make the make your robotic arm to work with the MoveIt. So make sure you have a good URDF which is having a proper collision boxes and everything. Once you have your URDF ready, then just use the MoveIt wizard in order to create this package. Okay, yes, so now we can see how to map to the gazebo. Okay, so currently we have seen the execution in fake controllers, but if you want to execute the trajectory in gazebo, then you have to configure the gazebo controllers. Okay, yeah, so the gazebo controllers or the ROS controllers you have to configure. So this is the ROS controller that we have automatically got from the wizard. Okay, so you have to just edit this configuration, or like I mentioned, right, like the MoveIt is actually a ROS controller client or ROS controller client. Yeah, so basically the ROS controllers are working using ROS actions. So the trajectory that is generated from MoveIt is sending to gazebo. So the ROS controller server is running on the gazebo. Okay, so maybe we can see the actual the Cortex gazebo package and MoveIt package. So you will get an idea. So yesterday we have set up the Cortex in this workspace, right? So you can see this is a already created MoveIt config for different configurations. So maybe we can just have a look onto this configuration. Okay, so this is the configuration that we have created. I mean, we have created our own. This is the configuration the company have created. Okay, so in the configuration now, if you check the configuration, you can check the kinematics. In the kinematics, they are using KDL kinematics plugin. Okay, and for the sensors, currently they are not using any sensors. And if you go to the 6DOF, you can find the ROS controllers for 6DOF. So these are the controller list. Okay, these are the controller list. Basically, like the controllers are basically follow joint trajectory, and the gripper controller is a type of gripper command. Okay, so if you go to, so this is a controller configuration in the client side, that is in the MoveIt side. And if you just go to the gazebo, okay, in gazebo side also there should be something, right? So it may be in the Cortex control or Cortex gazebo. So let's just check the launch file of the gazebo package, and you can find the place where it is starting the controllers. So mostly, yeah, so it is in the Cortex control package. You can find here inside the Cortex control package, we have the controller configuration. So this is a configuration in the gazebo side. So these two configurations should match, otherwise the MoveIt can't able to send the trajectory into gazebo or the real robot. Okay, so here what you can see is we have an effort controller which is having a type of joint trajectory controller, and inside this controller there are different joints, like 6 joints, and also we can also individually control the joints using joint position controller. And yeah, so these are the configurations of the robotic arm. And if you check the gripper, just a second, for the gripper we can see the configuration, this configuration they are using. Basically the server type is controller, server type is gripper action controller. Okay, so we have to set these controllers configuration in the gazebo side, and whenever we start the gazebo launch file, which is the spawn Cortex launch file, what happening is that, just a second, let me change the yeah, so when we start this launch file now, this launch file will start the gazebo, then it will start the controllers. You can see here different configuration with gripper and without gripper. So all these controller configuration will start here. Okay, then only the robot from MoveIt can communicate to the gazebo. So we can see the Cortex gazebo launch file. So that will be starting, I think, the gazebo with the just a second, it's showing some error, but let me see. Yeah, it's similar to the move group interface. Okay, let me see, just a second, because I need to build this workspace as well, because we have changed the MoveIt version. So that's why these errors are coming. Just a second, let me kill it. Okay, let me close this. Okay, so now I need to build the workspace, that is Catkin workspace, and just doing the Catkin make. So it will be building the repository with the new MoveIt installed, because we upgraded the MoveIt version. Okay, so it is important to build the packages that is depending on the upgraded packages. So let's wait for some time. Yeah, it seems like it's working. It is building at, I think it will take some time. Okay. So in the meantime, you can check like these instructions. You can try. They actually mentioned about these setup assistant, which is an very easy methods um, to create a config package, because you don't need to write your own inverse kinematic solver or motion planning. You can easily do by going through this wizard. So in order to perform inverse kinematics for a robot, just create the URDF and interface to move it. Okay. Yes. Just a second. Yeah, I think we have built it, and then we can run the simulation. I think it seems like the driver still fails. Yeah, the arm driver is still fails, but let's see the MoveIt and the gazebo will work or not. Just a second. Okay, the RVC is here. We can change into baselink and then load the motion planning plugin. Now we should see, okay, we can see the robot, and just do the motion planning and execute. Yeah, it seems working, but yeah, there are some nodes are like not working, but seems like these trajectory, these trajectories are sending properly to gazebo. You can see the motion that is planned in the RV's motion planning plugin is sending to the gazebo. So if it is a real robot, it will be sending these movement into the real robot. Okay, so it's very easy to create the MoveIt config for a package for a robot, and then finally what you can see is like you can move the robot in any pose, and even you can move the robot in a trajectory as well. So all these things are possible through MoveIt. Okay, so you can see this. Okay, yes, so that is the MoveIt setup assistant, guys. So I can give the reference, that is the Cortex ROS package. You guys can try it out. It is working good. So I think that is one of the reference that you can take in order to build your own robot or your own interface. I mean, for your ROS robot. Yes. So yeah, I think we have covered the setup assistant. Now it's a time for programming. So if you just go to the tutorial, you will get to know like these API examples, and MoveIt CPP. So I think because of I mean some issues with the example, I think we can do the session next class, because I need to set up this package. Then only you can also follow it. So maybe after setting the packages in my PC, I will be showing these examples. So this example basically using C++ and Python. So using C++ and Python, we are giving the goal position to the robot, and the robot will move accordingly. Okay. Yeah, so that is actually the examples about. Yeah, so there is a question from Kalpesh. Is there any standard procedure to create URDF? So Kalpesh, I think we have discussed the basics of URDF, and we created some URDF, right? So it's basically like for a robotic arm, it's a series of links and joints, right? So there is no standard procedures and all. If you want to create your own robot, you should have some set of links, and it is connected through some type of joints, right? So if you have a CAD model corresponding to the robot, then you can convert that CAD model into a URDF file through a plugin as well. Okay, some CAD software will help you to convert into URDF. But basically, in order to create URDF, I will suggest you to first start with I mean, if the robot is simple, if the joins and links connection is simple, you can try to create URDF manually, like just create link and just create joined using the XML itself, URDF tags itself you can able to do, but there is no standard procedures. Okay, it's basically like just following this thing like URDF tags. Okay, and there are some tools that is helping us to create the URDF. One is obviously the VS Code. Okay, so if you want to like create the URDF, I think the VS Code can help. Okay, so for example, if I am just opening the workspace, ROS Cortex, let me just open, and I can show you how to visualize the URDF. For example, just go to the description package, then robots, and this is a sacro file, right? And just a second, and there is an option in Visual Studio to visualize URDF. Just press Ctrl Shift and P, or just search for preview URDF. So on the right side you can able to visualize the URDF. So this is one of the efficient methods to edit and create URDF. Okay, so if you do some changes in any of the URDF, I mean any of the URDF parameters, that will automatically change here. Okay, so this is one easier tool to work with the URDF. Okay, and also some plugins in SolidWorks and Fusion 360 to convert the CAD models into URDF. Okay, so yeah, so now I think we can conclude today's session. I need to set up that packages, like there are some differences in some versions. The URDF that we are using and URDF, the MoveIt config that we are using is different, so I need to change that. Okay, so let me know if you have any question related to the setup assistant, which is actually the important part, because if you can create the setup assistant, I mean MoveIt config uses setup assistant, I think then it's a time for configuration. Like you can configure the controllers, you can configure the sensors, all this stuff. Yeah, so let me know if you have any questions. All these things you have to just practice, like mainly you can try this tutorial, official tutorial. I'm not sure the issue is with my side. I mean, is there any issue in my side? I need to check. but you can also just practice from the getting started. Okay, you can just check. Yes, so that's it, and I think there are some question. Kalpesh, I think, yeah. Yes, so today I will be uploading both the lectures. Yeah, yeah, I will be uploading. Okay. So, okay, guys, so see you next week. And next week, maybe first we can see the API and then jump into some new topics like nodelets and gazebo plugins. So these are two important topics in the sense it's a small topic but very useful topics. Okay, we can see with some examples. Yes. So thanks for attending. See you next week. I will be uploading the lecture soon. Okay. Okay then everyone. Good night.